Welcome. In this video, I'm going to go over the solutions for problem set 10.2 AB. So these are problems looking at reactions with alkanes and alkenes primarily. So question number 9 says, write the equation for the following reactions. And these are all combustion reactions, but two of them are incomplete combustion reactions, which really aren't that hard, especially when they let you know what the incomplete product is. So for 9A, if I start with pentane, we have to realize this pentane has 5 carbons, so it's going to be C5. And since it's an alkane, that'll be H12. We'll make it saturated. And if you can't remember these, there's a lot of places you can find these in the data booklet. Combustion then means it's combining with O2. And then typically we get CO2 and H2O, but they're telling you it's incomplete and you're getting CO, but you would still get the H2O. And then you're going to have to use your rap sheet or whatever to go ahead and balance this. So I'd put a 5 here for the carbon. I'd put a 6 here for the hydrogen. And then that leaves me 5 plus 6 is 11 oxygen. So I could balance this with a 5.5. Or if you prefer, you can double the whole thing and rewrite this as 2 pentane plus 11 oxygen yields 10 carbon monoxide and 12 H2O. And either of those is acceptable to IB. Letter B asks you to write the complete combustion of butane. So again, you either need to know butane is 4 carbons or you'll need to go looking for it. But it's C4, and that would make it H10 plus O2. And since it's complete combustion, you're going to get CO2 and H2O. And as you balance in, a 4 here and a 5 here, which again is going to give you an odd number because I'm going to end up with 8 and 5 is 13. So I'm going to end up with 6.5 O2, or the alternate would be to double all of these to 2, 13, 8, and 10. I'll just write those below in black. You could have 2, 13, 8, and 10 instead. And then letter C, incomplete combustion of propine. So propine is going to be, it's got the triple bond in there. It's going to be 3 of them, so it's going to be C3 and just H4, because it's 2 times 3 is 6 minus 2 gives me the 4 hydrogen. Or again, just sketch it out quick or look it up. Use your resources. That's a big part of this test, is knowing where to find your resources. And since it's incomplete in forming carbon, I'll just have C and H2O. I'm not bothering with the state symbols. IB usually specifies when they want you to include the state symbols. I usually give you an easy point for that. So then balancing, I would need a 3 here and a 2 here. And I'm balanced because it's just 2 oxygen. Number 10, write equations showing possible steps leading to a mixture of products in the reaction between bromine and ethane reacting together in UV light. So this is a difficult reaction to remember, but I think it's possible to remember the 3 main steps and then muddle your way through it. So the first thing is you have initiation, and they're not asking you to label these. I'm just going to label them to help you keep things straight. So the initiation means that the bromine, the Br2, gets split by the UV light. So that one, the initiation is very simple. You show the UV light as a catalyst, and then you just come up with 2 Br, and you put the little dot to show they're free radicals. So the initiation is a very easy step to keep in mind, and the termination is very easy because it can just be the reverse one. At least that's an easy termination step. So 2 of the 3 are quite easy to come up with. Okay, so this is over when 2 bromine, and now I don't need UV light because it's going to be an exothermic reaction, will form Br2. So it's the propagation that's the difficult one to keep in mind. But what you have to remember is the propagation always involves a free radical as a reactant, and it produces a free radical as a product. And so they said reacting with ethane, so go with what they gave you. I've got bromine free radical, and I have ethane, which is C2H6. So if these two were to react, the bromine could break off a hydrogen, break loose a hydrogen here, and give me C2H5 as the free radical, and then HBr. So a hydrogen could be pulled off by the bromine, which makes sense. Bromine's a very electronegative element. Pulls a hydrogen off and leaves behind C2H5 as a free radical and HBr. And then pretty much all your other propagation steps come from, how about the C2H5? What happens with that? Well, that could react with more of the bromine and go on and actually make your halogenoalkane C2H5Br. And now you have another bromine, which can go back up to the previous step and make more of the C2H5. So there's a variety of different steps that can happen, but at most generally they would want 2 propagation steps and usually just one of each. So these 4 steps show a complete transition of ethane and bromine gas to the halogenoalkane. Number 11 is looking at some of the possible addition reactions that alkenes will undergo. And the alkenes are far easier to figure out in my mind. So with 11A, I have CH3, CH2, CH, and they even show the double bond to a CH2, plus the hydrogen over nickel catalyst. And so this bond is going to break apart and give me another place there, and then the hydrogen is going to break apart. So when I look at what I end up forming, I have CH3, CH2, CH2, CH3. Well, that's just a 4-carbon alkane, or just butane. So usually whatever's being added is going to split in half and one go to each carbon on each side. So B is a little bit trickier because they say plus concentrated H2SO4, and what you have to recognize there is this is really plus water. This is really a hydration. And when water splits in half, you're really adding H plus and OH minus. So I've got very much the same thing. I've got CH3, CH with my double bond here, CH, CH3. And again, one of these bonds breaks open, and I put an H here and an OH here. And when I look at this, this is now an alcohol, it's butanol. And even though I put the OH on what appears to be the 3rd carbon, I would call this 2-butanol, or as IB likes to write it, they would write butan 2-OL, but you still pronounce it 2-butanol. And letter C then, this is probably one of the most commonly, well actually this isn't, this I'm thinking of BR2. So HBr, I've got my CH3, CH, CH, CH3. So again, I've got my double bond here. If I break that open, I put an H here and a Br here. So I'm going to make a halogenoalkane. So this one I would name 2-bromobutane. Number 12 then, what would you observe during the following experiments carried out in test tubes at room temperature? And this is really about the reactivity of alkanes versus alkenes, including cycloalkanes. Because the first one, some bromine water is added to cyclohexane in a test tube covered in aluminum foil. I would expect no changes to be noticeable. The cyclohexane is not going to be reactive with the bromine under those conditions. Okay, those bonds are just too tight. C is kind of the opposite of it then. Now I've got bromine water added to propane in a test tube in UV light, and the UV light is the catalyst to get this going. So the bromine is going to be hydrolyzed by the UV light, and then that's going to start the initiation, the propagation, termination. So the bromine is going to become part of the propane and form a halogenoalkane. So I would expect the bromine water to lose its color because the bromine is going to become part of the halogenoalkane. And then B refers to an alkene. A few drops of methylbenzene, the ENE is my hint that it's a alkene, are burned on a watch glass. And what you're supposed to realize is both alkanes and alkenes will burn, but there will be a sooty flame when it's an alkene, at least sootier than if it were an alkane. Number 2 from the practice, from which monomer is this polymer made? These are actually fairly easy. Just slice off a polymer or a monomer, and I see that I've got 3 carbons or 3 hydrogens and 1 chlorine around the carbon. So one of these had to be a double bond here initially, which means I must have started with A is the only one that looks like that. 3 hydrogens with a chlorine, and I had to have a double bond because that's what broke open and gave me the open bonding sites on each side of the carbon. So A would be the correct choice. Number 5, which substances are possible products of the incomplete combustion of octane? So incomplete combustion, your possible products is that instead of CO2, you could get CO, carbon monoxide, or if there's really a shortage of oxygen, you could get carbon. But the other thing you're always going to get is the water vapor. So hydrogen gas instead of water vapor, that doesn't happen. So B is the only correct choice. 6, which reaction occurs via a free radical mechanism? The free radical mechanism, that's the UV light acting as a catalyst with an alkane. So that is only A where we're seeing that happen. UV light allows an alkane, well, it allows a halogen to be hydrolyzed or split apart, and then allows it to combine with the alkane. So these others are all, this is an alkene, so that's just going to be an addition. And then this one's just a substitution. This one is a nucleophilic substitution, but really you just have to know it's the alkane that occurs with a halogen in the free radical mechanism. Number 8 asks, what will be observed after hexane has reacted with bromine in the dark? And again, hexane's an alkane, bromine's a halogen. That means it needs UV light as the catalyst for anything to happen. So if it's sitting in the dark, then A, no observable change will happen. If it was hexene, it would go ahead and react even without the UV light. Number 15 is a really kind of typical organic paper 2 question, and it's not that difficult. IB really sticks to the alkanes, alkenes, and alcohols for the most part with their questions. A few with the halogenoalkanes, but really they keep the mechanisms fairly simple compared to what they could be. So 15A says the reaction of alkenes with bromine water provides a test for unsaturation, just means a double or triple bond in there, in the laboratory. So if you put it in with an alkane, bromine with an alkene, bromine water with an alkane, there'll be no change. But if you put it in with an alkene or an alkyne, then we'll see a color change. So what IB wants to know is, what is the color change? So the brown bromine water that brownish color will become lighter than clear. Actually, and I don't mean clear, I mean colorless, because clear is not a color. And if you want to spell colorless with the U, go for it. But it'll become lighter than colorless. And again, that's not the same as clear. B says deduce the Lewis structure of chloroethene and identify the formula of the repeating unit of the polymer polychloroethene. So chloroethene since it's not dichloroethene, I know I have just 2 carbons. They're double bonded. That's what makes it ethene. And then there's going to be 1, 2, 3 hydrogen and just 1 chlorine on it. Oops, I can't draw chlorine here apparently. So there would be my single structure, and because it's a Lewis structure, I should also include the lone pair because it didn't say structural formula, it said the Lewis structure. And then identify the formula of the repeating unit. So this is where I redraw this with a single bond, the 3 hydrogens and the chlorine, and then I have to show the open bond on each end. And oftentimes this is put in brackets. And then letter C, besides polymerization, state 2 commercial uses of the reactions of alkenes. So it's production of alcohols is a big one, specifically ethanol. It's also the production of ethanoic and acetic acid. Acetic acid you know better as vinegar. So ethanoic and acetic acids are big ones. And it's also a producer of margarine because butter is an unsaturated fat, and then margarine, they partially saturate it. So it's not quite an oil, it's not quite the solid butter, it's in between, it's slightly healthier for you. But those are kind of the big 3